Morning, sir.
Good morning, madam.
Participants 11th தான் வந்திருக்காங்களோ?
ஆமா மேடம், இப்பதான் வர ஆரம்பிச்சிருக்காங்க.
5 minutes வெயிட் பண்ணலாமா?
மேடம்
Five minutes வெயிட் பண்ணலாமா?
வெயிட் பண்ணலாம் மேடம், வெயிட் பண்ணலாம். சாரி உங்களுக்கு இது அமைச்சிருக்கேன் பாருங்க ஜி, என்னோட இது இந்த ஜூம் ஜி. அது நான் என்ன பண்ணிருக்கேன்னா, அதுல வந்து
ஆமா சாமிங்கிற கோவம் வந்துச்சு, யானைக்கு கோவம் வந்துச்சு. அது half an hour ஒன்ஸ் சின்ன டம்ளர்ல ஒரு ஜூஸ் கொடுங்க. லெமனு, மாதுளம்பழம், ஆரஞ்சு சின்ன டம்ளர்ல கொடுத்தா போதும். அது அந்த ஸ்ட்ரென்த் உள்ள போனாலே போதும். இவ்வளோ பெரிய டம்ளர்ல போட்டு ஒரு நாள் பூரா ஒரு அரை டம்ளர் குடிப்பான். இதுல எது குடிப்பா, அரை மணி நேரத்துக்கு ஒரு குடித்தாலே போதும். இருபத்தி 2 பேர் இருக்காங்க. யுவராஜால இருக்காரு. யுவராஜா ஜி ராகுல் அவன், எஸ் ராகுலா. ஆனா அங்க சர்டிபிகேட் அப்புறம் தீபிகா கவின் வந்துட போகுது. நிறைய பேர் மெயில் ஐடி தான் அப்படியே கொடுத்துருக்காங்க, அதனால ஒன்றும் பிரச்சனை இல்லை. இதுல மட்டும்
ஹலோ, ஆமா இல்ல இல்ல, அது யார்? அது தீபிகா கவின், அவங்க பாட்டு பேசிட்டே இருக்காங்க, கொஞ்சம் மியூட் பண்ணி விடுங்க அவங்கள.
ஓகே ஓகே மேடம், எல்லாம் மியூட் பண்ணிட்டாங்க மேடம். சரிங்க மேடம்.
Welcome to all the participants. I am Tamil Selvi, HOD of EEE Department, R.M.D Engineering College, and we are organizing this webinar based on the design of processor circuits with Verilog HDL. And Mr. Sai Kumar, our
Hello.
assistant professor, is going to conduct the first session. And the next session will be from an industry person. So I hope this.
Madam.
Hello sir.
நீங்க பேசுறது
வாய்ஸ் கேக்கல.
கேக்கல மேடம்.
கேக்கலையா?
கேக்கல மேடம், கேக்கல மேடம்.
சரி, நான் வரேன்.
மேடம் நீங்க பேசுறது எனக்கு கிளியரா கேக்குது மேடம்.
கேக்குதா?
கேக்குது மேம், எனக்கு கேக்குது.
சார் சாய்குமார் சார், உங்களுக்கு கேக்குதா? சாய்குமார் சார், can you hear me?
மேடம் கேக்குது மேடம், கேக்குது.
மேம் கேக்குது மேம். குட் மார்னிங் மேம், கேக்குது மேம்.
ஓகே.
கேக்கலாம் மேடம்.
Okay, and welcome to all the participants. And you know that we are in the lockdown period. Even then, we have to enhance our skills in order to enhance our knowledge. Students also. That's what we thought of conducting this kind of webinar for the students as well as for the faculty. And always maintain the social distancing and take care of your health, your family members, as well as maintain the social distance and be safe in your home. And I am handing over the session to Sai Kumar. Sir, you can conduct the session, sir.
Okay, sir. Thank you, madam. Okay, good morning to everyone over here. So today we'll be seeing about how to design some of the processors. This is a first webinar series with where we discuss about how to design processor circuits using Verilog HDL. Most of the staffs might have very well heard of the microprocessors such as 8085 and 8051. So the main difference between both of this is one is a processor used for general purpose application and another one is a microcontroller. Structure wise, if we see the difference means processor is mainly designed for executing software application. It is a software oriented device. Whereas if you go for a microcontroller, it is a hardware oriented device. So how do we find whether it is a software orientation or hardware orientation? If we see means software oriented devices will be having more number of software interrupts supported by it. Whereas if you go for a microcontroller, you'll be having more amount of hardware interrupts. So hardware oriented processor is called as a microcontroller. Software oriented processor is called as a microprocessor. So with this basic introduction, today we'll be seeing about how to design some of the arithmetic elements in a microprocessor or a microcontroller. So I just share my screen over here. So this is my topic, the design elements of non-pipelined processes. So what is the main difference between a pipeline and a non-pipeline means? In a pipeline, each instruction will be continuously read from an instruction memory while other processes are executing. So what are the main processes that are associated with a processor means? First you have to read an instruction. Next one, you have to read the operands of an instruction. Next, you have to perform the operation present in the instruction. And finally, we have to store the result of the instruction in a particular memory location or somewhere in a register. So the microprocessor or the microcontroller, they keep on performing these set of operations in a repetitive manner. So this is a webinar series 1. Why I'm specifically mentioning it is because here we'll be dealing with the design of arithmetical elements that are required for designing a arithmetic logic unit. So if I'm going to directly go with the design of arithmetic logic unit, it might be a bit creating a headache. So I want to just discuss about the various methods, how to create arithmetic elements and how to use the Xilinx software in order to create it. And what are all the set of things to be followed in order to create a circuit, because any teaching faculty might be aware of the 8051, 8085 process circuits architecture, but this session provides an insight into how do we implement it using a software called as a Xilinx software. So before directly going into the topic of design of arithmetical elements, we'll be just seeing about some basic information so that we can easily correlate with the subject. So the first one is, so these are some of the basic terminologies we need to understand. The CPU, word, bus, memory, IO or peripheral. So in order to avoid unwanted definitions that are given in the books, I'm just reducing it to a form that could be easily grasped by the general public. So CPU is nothing but a central processing unit. It is an electronic circuitry whose main purpose is to execute instruction. This instruction can be either present in a separate memory called as an instruction memory, or it can be present in the form of an application in a data memory. So next one, we'll be seeing with a word called as word. So word is nothing but a general purpose term where we'll be referring to any n-bit data. The data can be either a signed data or an unsigned data. So this data can be referring to both an instruction as well as a data required for the computational purpose. So next one, bus. Bus is nothing but a group of wires which are used for carrying a similar signal. For example, a data bus can carry only data signals, address bus can carry address signals, control bus can carry control signals. So what is meant by a data signal means it is the signal which is flowing within the microprocessor and between a microprocessor and a memory and between a microprocessor and a peripheral device. So next one, finally, we will be going with a peripheral. Peripheral is nothing just like a port. How does a city is loading or unloading the various quantities through a ship or through a port? The CPU also receives an information and sends an information by means of a specific device called as a port. So any microprocessor or a microcontroller cannot directly communicate with a peripheral device. It has to communicate only by means of an interface. So with this general introduction, this is the block diagram of a microcomputer. It consists of basically 3 modules. One is called a CPU, one is called a memory, one is called an IO. Here the CPU module is the main thing which consists of all the things that are required for executing an instruction. So what are the main things that are required for executing an instruction means? Generally we'll be saying about the term called as execution. So execution is nothing but performing some form of arithmetic or logical operation is called as an execution. So some of the basic terminologies must be understood in order to understand this Verilog coding. Next one, this memory can be either a data memory or it can be a program memory. If both of them are present within a same chip, it is called as a von Neumann architecture. If they are present separately means it is called as modified von Neumann architecture or a hardware architecture. Next one, we do have the peripheral devices such as a keyboard, teletypewriter, telephone, or any form of devices through which a human can understand the operation that is performed by a CPU. So the main purpose of these three buses is address bus is used for identifying a particular location within the memory or IO device. The data bus is used for either transferring data to the memory device or to the IO device, or else receive a data from the memory device or an IO device. Last one, control bus, is that these all forms of data communication cannot take place in an uncontrolled manner. It has to be controlled by means of certain signals. That signals are provided by the control bus. So this is the basic circuit diagram, block diagram of a microcomputer. The basic difference between the microprocessor and a microcontroller can be understood from this diagram. So the typical components what are present within a CPU could be mainly these three things. One is called as a register, arithmetic logic unit, and control circuitry. So registers, they will be used for storing the data. Arithmetic logic unit for performing arithmetic and logical operations. And last one, control used to control the data flow into the microprocessor, data outflow from the microprocessor, data flow into the arithmetic logic unit, data outflow from the arithmetic logic unit. How does a microprocessor must behave according to the instruction it has received? In order to decode an operation, we require a control circuitry. So these registers are nothing but D flip-flop based devices. Arithmetic logic unit is nothing but a combinational circuit. Control circuitry, it can be either a combinational circuit or a sequential circuit. For example, if you go with ARM microprocessor, they are using combinational circuit form of designing a control circuitry, that is called as hardwired circuit. Whereas if you go with all the Intel process what we are studying in our syllabus, with anonymous syllabus 8085, 8051, 8086, all these are called as microprogrammed circuitry, means they will be using a sequential circuit for implementing the control circuitry. So this register and the ALU together is called as a data path, because these are the main things through which a data will be flowing through a bus. Next one, this is the basic difference between a microprocessor and a microcontroller. Last diagram we just saw what is the block diagram of a microcomputer. It consists of a CPU module plus a memory plus a IO device. If I'm going to segregate the CPU module alone and place it within a chip, it becomes a microprocessor. If I'm going to segregate all these, if I'm going to integrate all these three things, CPU module plus memory plus IO, and the list of buses which are associated with them, namely the data bus, address bus, control bus, within a chip, it becomes a microcontroller. As already said, microprocessor is a software-oriented device. Microcontroller is a hardware-oriented device. So in order to just know how to, simply speaking of a CPU will not provide an insight into how to be code a particular circuit. So just for having a basic understand of how does a microprocessor will be looking like this. It consists of, these are the basic circuits which are present within a processor. Why specifically 8085 means because these two processes are mainly taught within the Untitled syllabus as well as throughout the Indian academic curriculum. So teaching into the academic curriculum, we need to know 5 main processors. One is called as basically 8085, 8086, 8085, ARM processor, and PIC microcontrollers. So these 5 processors have to be necessarily known in order to survive in India. So as a basic introduction into the form of designing, I'm just explaining this various concepts. So this is the basic circuit of a microprocessor. It consists of an arithmetic logic unit. This arithmetic logic unit basically consists of an accumulator, a register, a flip-flop, a flag register, and arithmetic logic unit. So this flag register, what is the main purpose of these 3 things is, means accumulator, it is going to act as a one of the first operand of the arithmetic logic unit. What is the main difference between the accumulator present in 8085 and accumulator present in 8051 is accumulator is a general purpose register in 8085, whereas it is a special purpose register in 8051. Next one, temporary register, it is going to hold the second operand of an arithmetical or logical operation. Last one, the flag indicates what is the status of the result produced by an arithmetic logical unit. So what can be the it is going to tell the whether the result produced by the arithmetic logic unit is a positive number or a negative number, whether it has even number of ones or odd number of ones, whether it has a carry or no carry, whether a borrow has been produced during a subtraction or not, whether an auxiliary carry has been produced during addition or not. So these are the whether the result of an arithmetic logic unit is 0 or non-zero. So these are the various things that can be understood from a flag register. So what is the main purpose of this flag register is it is mainly used for performing all forms of branching operations. So where do we go for this branching operations? If you see means if we directly map with the high level language programs like C, C++ or Java, whenever we want a subroutine branch, that means whenever we are going from a main routine to a subroutine, or whenever there is a error occurring, that is called as an exception, we will be making use of this flag register contents in order to move from the main routine to subroutine and we return back from the subroutine to the main routine. So this is the basic structure of a microprocessor. This may not be necessarily followed all the microprocessor. The complexity of the microprocessor increases with the number of bits it can go into process. So how do we decide whether a processor is a 8-bit processor or a 16-bit processor is based upon the number of bits the arithmetic logic unit can perform. So arithmetic logic unit in 8085 is a basically 8-bit arithmetic logic unit. So the microprocessor is also defined as a 8-bit microprocessor. So these are the various things. Next we'll be seeing with the microcontroller. So in order to differentiate, as I already said, we do have the CPU module plus memory plus I/O interfaces together within a single chip. This is called as a microcontroller. In this microcontroller, we'll be having the CPU plus separate memory for the RAM, separate ROM, and we do not have the various peripherals over here, but we have the interfaces that are required for the peripherals over here. So what are the peripherals communicating devices? If you see means we do have the 4 8-bit ports over here that is going to communicate with the external peripherals. So leaving behind those things, here are the arithmetic logic unit. The basic structure of you see, removing the temporary registers and everything if you see means, basic structure of an arithmetic logic unit in both this hardware architecture is the same. It consists of 2 input quantities. One is called as an accumulator, one is called as a B register, another one is called as a arithmetic logic unit. Last one we do call it as a flag register. In 8085 it is called as a flag register. In 8051 it is called as a program status word. So to just many might not be knowing what was the practical application where 8085 was used. So this slide provides you some general information about where the 8085 microprocessor is used. Generally, as per academic thing, we will be using it only as a trainer kit over here. But 8085 kit were used in the practical applications in various military-based helicopters and landline phones and basic microprocessors and microcomputers in early days. So general operating frequency of a 8085 processor is between 3 MHz to 6 MHz. So the 8085 processor was not constantly operated with the 3 MHz or 6 MHz frequency based upon the application required, based upon the nature of based upon the complexity of the project, frequency has been selected over here. So many might not be knowing that India also has processed some of the chips. So these are some of the chips that has processed by Indian people. Most of them has been processed by IIT Bombay, IIT Madras, ISRO, Sankhya Labs, CDAC, and Signal Chip. So the Shakti processor as the new the list of processors that are being manufactured by IIT Madras. All of them are synthesizable, Verilog based codes that are available. So next one, Vikram processor that has been used for various navigation, control, and guide processing applications. So these are some of the processors over here. So to general overview of to consolidate whatever I have said now, these are the basic microarchitectural components in your processor. So you may not fear what is meant by a microarchitecture. Microarchitecture is nothing but another name for hardware architecture. In order to create a processor, we require these hardware elements within a microprocessor. Then only we can qualify it as a microprocessor. So read-write memory, read-only memory. So this read-write memory generally will be mentioning it as a random access memory, but it is actually a wrong way of saying it. Random access, both read-only as well as read-write memories are random access memories. So random access, it indicates the technique by which a processor can access a particular memory location in that memory. Random access means it can access any memory location at the same time. For example, if I am having a memory of having 600 location, if I am accessing the first location with 6 nanosecond, I will be accessing the 600th location also with 6 nanosecond, 300th location also with the 6 nanosecond, 120th location also with the 6 nanosecond. So all the memory access times will be the same. So that is called as a random access. The correct way of marking it is read-write memory, read-only memory. So data memory, generally they may mention it as a random access memory over there, but the actual way is it is called as a read-write memory, read-only memory. So these components must be compulsorily present in order to qualify a chip to be a microprocessor or to be a microcontroller. So in order to explain something about the arithmetic and logic elements in these both processors, if I'm directly going with arithmetic logic, it might be a bit mind-boggling for you. So just before going into that, let me tell you what are some of the basic arithmetic and logic elements present within your arithmetic logic unit. Then we can finally see with the arithmetic logic unit construction. So generally, there is a specific word called as a single precision, multi-precision. No need to get feared over here. Single precision means as far as a 8-bit processor is concerned, 8-bit arithmetic logical operations is called as a single precision. Multi-precision means 16-bit arithmetic and logical operations that are performed by the 8-bit processor or a 8-bit controller. So both these microprocessor and microcontroller perform signed operation. Signed operation means the integer, it has both positive value as well as a negative value over here. So some of the basic operation that will be creating an insight for you in order to understand this concept is, it consists of a signed addition operation, signed subtraction, signed increment operation, decrement operation, logical operations, and or not XOR operations. So these are some of the operations that could be frequently performed over here. So what are the basic components is, again to this thing, rephrase over here. It consists of 2 data input registers, arithmetic logic unit, result register, program status word, flag register. So these are some of the basic things over here. So let us directly go with the let us directly go with how to design a microprocessor arithmetic instructions over here. First you have to go with the Xilinx ISE. The software is available at a free version over here. It is called as Xilinx ISE Webpack. So first you have to go with the file option. You have to select new project. Then you have to type. Let us already go with the existing project over here due to lack of time. I have designed some of the arithmetic logical operations over here. We'll go with the addition operation. So for an arithmetic logical operation, we require some of the adders over here. So this is the basic structure of your adder. You see with 8085 means the accumulator is a 8-bit accumulator. So we are mentioning it as input 7 0 accumulator. That means it has the 7 is the most significant byte, 0 is the least significant bit. Another one, we have the temporary register over here. So these are the basic, this is the structure. The adder is going to perform some of the accumulator and the temporary register, and it is going to store the result in the sum over here. So the status registers are for the adder are given as carry, 0, sign, parity, and auxiliary carry. The carry is nothing but the value that is coming out from the most significant bit of the result. So I have assigned the carry to the most significant bit, the value coming from the 9th bit of the result. So next one, for assigning the value of 0 flag, I have to just check whether the result is 0 or not. So I am using a conditional assignment operator over here. This will be checking whether the result is equal to 0. If it is equal to 0 means it will be assigning 1 to the value of z, or else it will be assigning a value of 0. Next one, the sign bit indicates whether the result of an addition operation is a positive number or a negative number. This parity bit, it indicates whether the number of ones is 0, whether the number of ones is even or not. So for getting an even number of ones, I have to XOR all the bits of the result registers over here. So auxiliary carry indicates whether there is a carry occurring from the least significant bit of digits over here. So this is the technology schematic of a adder. So this is the internal circuit diagram of the 8-bit adder of 8085 circuit. So this is the overview. In this over here, we do have the accumulator as one of the registers over here. Next one, we do have the temporary registers. And finally, we do have the sum with the accumulate auxiliary carry, parity, sum, and finally 0 over here. So this is the basic thing of a adder of a 8085 circuit. So with this, since because of lack of time, I'm just provided about the basic information about the various how to design a arithmetic logic unit using Xilinx DSC. Do you have any doubts, means you can just clarify over here now. Tell me, sir.
Hello.
Tell me, sir.
Hello, sir.
Tell me, sir.
Processor and controller. What are the application point of view the processor or controller is used in the particular application, sir?
You see, processor means we will be using it generally for executing all forms of applications, sir. All forms of application in the sense, software application that is associated with a particular OS. For example, ARM processor, it will be used for executing Android-based OS-based applications. iOS OS-based application. The main purpose of your processor is to execute all the set of application that is associated with an operating system. Whereas if we go with a microcontroller, its main purpose is to control a set of peripheral devices repetitively based on some environmental input what it is receiving. So it is a hardware-oriented device. So all forms of general application, for example, TV remote control, then air conditioner remote control, they will be employing controllers within them. Whereas if you go for process, you will not be employing process for performing simple control operation. You will be using it for executing a larger number of applications. For example, you cannot run a MS Word inside a 8051 microcontroller. The MS Word, the amount of application, the amount of instructions that is being designed is, it can be only run in a microprocessor. Whereas similarly, you cannot run a embedded system based program inside a microprocessor, because the microcontroller components, peripherals, everything has been designed for a particular set of applications. So this is the main difference between a microprocessor and a microcontroller. Microprocessor is for mainly executing OS based applications. Microcontroller is mainly used for hardware based applications. So that is
Okay,
the
sir.
main
Okay, thank you,
difference.
sir.
So
Okay,
is
thank
there
you, sir.
any other software available like Xilinx in the market?
The Xilinx ISC Webpack it is available for free, sir. As then you have the ADS software for performing transistor level simulations. The Xilinx is used for only up to gate level simulation. Gate level means you can perform using AND gate, using basic logic gates, you can represent all the circuits. But if you want a
Okay, sir.
transistor level simulation means you have to go with the ADS. If you do not want any form of these circuits, I want only simulation waveform means you can go with the model sim, sir.
Okay, thank you, sir.
Is there any other doubts?
Sir, is there anybody fabricating IC chips apart from the listed ones, sir?
Sir, India or foreign, sir?
Here, India only.
India